Hello, ladies and gentlemen of Algebra 2. Welcome to your first video for Algebra 2B, talking about properties of exponents and scientific notation. So I need to be able to figure out the properties of exponents and what happens when I multiply and divide them, and then use expressions written in scientific notation. So let's kind of get right here. Simplify with powers, with exponents, means you have to no parentheses, no negative exponents. You can have none of these. No parentheses, negative exponents, and you should see each variable written only one time. That means you do not have x squared, and then you have a y, z, a to the fifth, b to the fourth, and then you have another x to the fifth over here. You have to combine these two. All right? Do not have this. So, when you're multiplying, you actually are adding the exponents. Okay, so this is going to be 2, 3, 4. So that's going to be x to the ninth. Now, think about this a little bit. Think about what each one of these things means. This means x times x. That's x squared. X to the cubed is x times x times x. X to the fourth times x times x times x times x. So then I put all those together. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, x to the ninth. That's why. Think about what it actually represents. So for number 2, for the bottom one here, m and m squared, well, I got to think about this as m to the power of 1, so that's going to be m to the third. All right, don't make the mistake. Everyone magically thinks if it's just m, that means it's m to the 0. That is not true. So there's my answer. M to the third. So if you're taking power of a power, so you're going to take 2 to the fourth, so you're going to equal y to the eighth. There's my answer. All right, y to the eighth. So I multiply. So if I think about it, this is y squared, y squared, y squared, y squared. That's going to be y to the eighth. So now down here for part 2, think about what this means. Now, I've got this entire parentheses raised to the power. That means I need to take each part raised to the power. So I need to take 4 to the third power, x squared to the third power, y to the third power. I need to take all those raised to the third power. So that means this is going to be 64. This is going to be x to the sixth, y to the third. A lot of people, a lot of kids like to do just the variables. Okay, you got to remember, you got to take that to the third power as well. This, and this all have to be raised to the third power. There's my answer right there. So, quotient, dividing. I'm going to subtract their exponents. Okay? So I've got m to the 11 and m to the fifth. So that means where do I have more? In the bottom. By how many? 6. So my simplified answer is going to be 1 over m to the sixth. Another way to think about it. Draw this out once just to kind of help you visualize. So that's 7 on the top, 3 on the bottom. Those cancel, those cancel, those cancel. How many do I have left? 4. Where are they? In the top. So that's just going to be a to the fourth over 1, or just a to the fourth. That's my answer right there, a to the fourth. So negative exponents. Negative exponents just mean flip it. Okay? Flip where it is. If it's in the bottom, move it to the top. If it's in the top, move it to the bottom. And when you do that, you make the exponent positive. Okay? So, now the question is, what's being raised to the negative power here? Well, just the a is being raised to the negative power. So I'm going to move just the a. I will leave the 3 on top. There's my simplified answer. All right, for number 2, it's negative in the bottom. That means I need to move it up. So this is just going to be 2x to the third, and you're done. So, 0 exponent. Anything in the entire world raised to the power of 0 is always going to equal 1. So this whole thing is raised to 0. My answer is 1. For number 2, look, just the x is raised to 0. So this is like saying 5 times 1, which is just going to be 5. So simplify, write your answers only as positive exponents. So look, multiplying. So I'm going to multiply the numbers. So that gives me negative 12. Now I start multiplying things here. So x squared and x squared becomes x to the fourth. y squared and y to the fourth become y to the sixth. So my final answer is negative 12 x to the fourth y to the sixth. So now number 2, a to the negative 2, a to the squared. If I multiply those, I end up with a to the negative 1, b to the fourth, because there's nothing else for b to multiply, c to the negative 1, same reason. But now I can't leave it like this. All right, I've got to move some things around. So a and c both need to go in the denominator. So I'm going to have b to the fourth over ac. There's my answer. Boom, right there. So now if I look here, if I simplify this, I got to think about, where is there more and by how many? So here, the bottom has got 5 more. So that's just going to be 1 over p to the fifth. There's my answer. All right, for number 4, I'm going to break this up. I think it's just easier to do that. I know it takes an extra step, and, heaven forbid you have to write more than you think you should. So, but look here. Before I even do that, before I even start doing that, I can simplify these two in the bottom. So if I multiply those together, I get c to the ninth times d to the third. There's no d in the denominator, so I just put 1. So now, don't forget your rules. A lot of kids will do this, and then magically 12 will show up. That is not the case. I don't want 12. Remember, it's still dividing numbers. You're not changing that. So that's going to be negative 5. For the c's, I've got more c's in the denominator. There's 4 more c's in the denominator, so that goes there. D to the third, I can't do anything with. So when I put this together, I'm going to end up with negative 5, d to the third on top, c to the fourth on bottom. There's my full simplified answer right there. So taking a look here, raising it to the fifth, and a good idea, a good thing that I do is I rewrite it with everything being raised to that power. So I take negative 2 to the fifth power, p to the third to the fifth power, r squared to the fifth power. So negative 2 to the fifth, I believe that's a negative 32, and it is. So power to a power here means it's going to be p to the 15th, r to the 10th. You do not add those. Power to power means you multiply. So there's my simplified answer right there. So here, if it's negative, all right, and if I follow my rules, here's kind of what's going to happen. So if I just follow my rules, and then I'll come back and show you kind of a different way. If I just follow my rules, that means I have a to the negative 3, 4 to the negative 3, which means the next thing I want to do is flip them. So I put 4 to the 3 on the bottom, a to the 3 on the top. 4 to the third power is 64. So there's my answer. So that's what I want to do. If this whole thing is negative, follow your rules. Everything gets raised to the power, but if it's negative, I've got to flip it. And then 4 to the third, you can simplify. So I'm going to simplify it. All right, so let's talk about standard notation, standard deviation, or scientific notation. Scientific notation you see a lot in science classes. Remember, you're talking about really, 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 really big numbers or really, 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 really small numbers. Now, kind of a couple rules. One, this number has got to be between 1 and 10, okay? If it's 0.90, that's too small. And if it's 10.1, it's too big. Okay, it's got to be between 1 and 10. It can be equal to 1, cannot be equal to 10. So it's got to be an integer. This exponent has got to be an integer. It can't be decimal exponents. So let's take a look here. Density of an object in grams per milliliter is dividing the mass by the volume. Okay, so a sample of platinum has a mass of 8.4 times 10 to the negative 2 and a volume of 4 times 10 to the negative 6. Use this information to calculate the density of the platinum. So I've set up a little division problem here. So here's all I'm going to do. I'm going to divide these numbers and I'm going to subtract these numbers. Okay, so what I end up with is 8.4 divided by 4. So that gives me 2.1. Then negative 2 minus a negative 6 is going to become 10 to the positive fourth. All right, I take negative 2 minus negative 6. All right, I get that from there and there. And just to be sure, if you can always do this, you can always kind of double check. 8.4 times 10 to the negative 2, that means that I'm going to move, the negative 2 means I move it 1, 2, so this is really 0.84. And on the bottom, 4 times 10 to the negative 6, sorry, that's a negative 6, means I'm going to move it 1, 2, 3, 4, 5, 6. So I'm going to go 0.00004. Those are the two numbers I'm dividing right here. These are the two numbers I'm dividing. So if I do that, 0.8084 divided by 0.000004, I get 21,000. So if I convert that back, it's 1, 2, 3, 4, and that's what I end up having right here. Okay, so it's just working with that without having to multiply it out. Now these two are not too tough, you can do that, but after that things can get a little hectic. So after the sun, the next closest star is Alpha Centauri, which is 4 times 10 to the 16 meters away. How long does it take Alpha Centauri to how long does it take light from there to reach Earth? So light travels at a speed of 3 times 10 to the 8 meters per second, and Alpha Centauri is that far away. So distance equals rate times time. So my distance is 4 times 10 to the 16th. My rate is 3 times 10 to the 8th times time, because that's what I'm looking for. How long does it take? So I'm going to divide this. So I end up with 4 divided by 3, which is 1.3 repeating, but I'll just go 1.33, and then I'm going to subtract times 10 to the 8th. So it's going to take that long, that many seconds, for light to reach here, because that's meters per second. All right, so that's 1.33 times 10 to the 8th. That means you got to move this decimal place over 8 places to kind of get an idea of how long it's going to take. All right, last problem here. So the moon is this far away. How long will it take a radio signal traveling at that speed to cover the distance? So, moon is sending out radio waves. We're doing this, 3.84 times 10 to the 8th. And then again, you're dividing, it's distance divided by rate is going to give you time. So 3.84 divided by 3 is going to be 1.28. Then 8 divided by 8, this is actually going to cancel itself out. So you're going to be left with 1.28 meters per second. That's how fast it's going to be. Well, actually, since you're looking for how long, it would just be 1.28 seconds. All right, play around with this. Come talk to me with questions and get after this stuff.